Hi guys, welcome to the Integrated Math 3 Module 12 test review. I'm gonna be going over a lot of these problems. Right now I gotta let you guys know right off the bat that I'm not going to do every single problem on this review. I was counting through them and there is way too many for me to do in one video and it would be way too long. So what I think I'll do is I'll probably do one problem per section and then I'll have you guys do the other problems in the exact same section. So for example, for number one, I'll probably only do number one, part A I mean, and then you guys will be in charge of doing B and C. Okay, so let's get started. Okay, so for number one, the first thing that we need to do is fix it because there is a typo on it. I put 281920 as the last term, but it actually should be 81920. So basically get rid of that 2 in front. Okay, it's just 81920. I must have clicked on the wrong key when I was typing this up. Okay, so it's just 81920, and then it's able to be solved. With the 2 in front, you can't actually find the sum because 281,920 is not part of this series. All right, so let's go ahead and get started. First thing you're going to do is figure out if it's arithmetic or geometric by looking at the numbers to see how they're changing. Actually, it's much easier in this one. It says here that it's geometric. But let's pretend that I didn't tell you that it's geometric. So you would go through the numbers and see how it's changing, right? You add 15 or you add 60, which are which would make it arithmetic if that was the same number. But they're not the same number, right? 15, 60, those are completely different. But you can see that it's being multiplied by 4, right? Times 4, and so on. So that means that R is 4. And that means that it's geometric with R equal to 4. So we're going to find the sum of a geometric series. This is the formula for the sum of a geometric series. S of n equals A times 1 minus R to the power of n over 1 minus R. That's our formula that we're going to use. In order to use this formula, you need to know what R is. We got that. You need to know what A is. Alright, let's write that down. A represents the initial term. In this case, I can see that it's 5. And you also need to know what N is. N is the number of terms in your series. So that we don't know. N is how many terms there are. We don't know what that is. So what we're going to do is we're going to solve another formula, the explicit rule formula, which looks like this, right? Because it's geometric. Just real quick, this is another one that you guys also know, right? But this one's for arithmetic, so we're not going to be using this one because that's for arithmetic sequences. We want the geometric one, which is the one that I wrote right there in black. So using that formula and plugging in the correct numbers, A is 5, R is 4, to the power of n minus 1, we don't know what n is, so we leave it as n minus 1. For f of n here, you plug in the last number in your series. Because when you plug in that number, what you're basically saying is, I'm solving for n, which is the position of that number. What position does that number hold? And that basically tells you how many numbers there are, how many terms there are in your series. So you're going to plug in 81,920 right here, and we're going to solve this. Alright, to solve this, the first thing I'm going to do is I'm going to divide by 5. Divide by 5. That cancels, leaving me with 4 to the power of n minus 1 equals 81,920 divided by 5, which is 16,384, according to my calculator here. And now what you need to do at this point is figure out what n is by trying to see if this number is a power of 4. And it should be, because otherwise we can't really figure out how many terms there are. So 16,384 should be 4 to the something power. And basically it's up to you to figure out what that power is by using your calculator. So what you should be doing is saying on your calculator, let's check 4 to the 5th power, see if it works. 4 to the 6th power, see if it works. 4 to the 7th power. And what you want to do is get this number right here. So let me test a couple numbers. 4 to the 5th would be 1024, too small. 4 to the 6th, 4096, still too small. 4 to the 7th, there it is, 16,384. So 16,384 is the same as 4 to the 7th power. These two are the exact same thing, so I can replace this with 4 to the 7th. And now I can solve I can find the value of n by simply comparing this 7 to the n minus 1. So you make a new equation that says 7 equals n minus 1. You can only do this as long as you have two sides that have the exact same base, right? Two powers that have the exact same base. Since the bases are the same, that must mean that the exponents are the same. Now you can solve it by simply adding 1 to both sides. Add 1 to both sides and you're done. N equals 8, right? Because you add 1. So we're going to write it over there. And there you go. Now we're ready to find the sum. Okay, so all that work that we did was just to be able to find what n was, how many terms there are in my series. Now that I found it, I can use these three, plug them in here to find the total sum. Okay, here we go. S of n, which is 8, equals a, which is 5, times 1 minus r, which is 4, to the power of n, which is 8, all over 1 minus r, which is 4. There you go. Equals 5 times, in the denominator, 1 minus 4 is negative 3. For the numerator, 1 minus 4 to the 8th. That means 1 minus, let me see what 4 to the 8th is. Calculator says 65,536. Like that. Alright, keep going. So that means 5 times 1 minus 65,536 is 65,535, negative. Divided by negative 3. Do that division. So it's 5 times, let's divide that by negative 3. Divided by negative 3, I get 21,845. 845. Finally multiply that times 5 and you're done. And I got 109,225. That is the total sum of all of those terms. Alright, now I'm going to let you guys work on B and C on your own. So go ahead and try them on your own, please. And then come back and check your answers. I'll post the answers right now in a couple of seconds. So go ahead and pause it right now and do it on your own. Okay, so here you go. Here's B and C. In B, A is negative 4, R is 3 because it's being multiplied by 3 every time. And I found n equals 9 by using the explicit rule for the geometric sequence. A is negative 4, R is 3, and I plugged in negative 26,244 for f of n. Divide by negative 4, I got this positive 6561. Then, like I said, you check with your calculator. What number with the same base, so 3 to the something equals 6561. I found that 3 to the 8th works. And then I said n minus 1 equal to 8, because since the bases are the same, the powers are the same. And then I add 1 to both sides and I got n equals 9. So that's how I got that. Then I took these three numbers and I plugged them into the series formula, right? This is a geometric series, so I use this formula. A is negative 4, R is 3, N is 9. And at this point, it's pretty much calculator work. Just got to be careful that you're doing the work correctly. 3 to the 9th is 19,683. 1 minus that is negative 19,682. 1 minus 3 is just negative 2. I divided this, I got positive 9841, and then times 4. Oh, there's a mistake here. Times negative 4, right? Let's fix it. Yeah. This should be negative 4. Which means that this should be negative 39,364. There you go, that's the correct answer. Now I'm going to have to watch out for C. So there's the final answer for that one. And that makes sense because all of the numbers are negative, so your final sum should be a negative number. Okay, for C, I did A is 2, r is -4 because it's being multiplied by -4 every time. The number of terms, once again from the explicit rule, 8192 is the last term, 2 is a, and r is -4 to the power of n minus 1. Divide by 2, I get 4096 times r to the power of n minus 1. And then -4 to the 6th power. This one I checked on a calculator. I did -4 times to a bunch of powers until I found the one that was 4096. And why -4? Because I want it to be the exact same as this one, right? They want to be the same base. So I got 6, and so n minus 1 is equal to 6, and I got, plus adding 1, I got n equals 7. Once you get that one, I took these three, plugged them in here. Now I gotta double check that I didn't make mistakes like in the last one. -4 is r, a is 2, and n is 7. The first thing you do here, this is where you do have to be kind of careful because it's -4 to the 7th power. That's going to give you a negative number. But then 1 minus that negative number, that's why I have a plus here. Same thing here, 1 minus a negative becomes plus 5. So it's 16,385 divided by 5, 3277 times 2, 6554 is your final answer. Alright, let's move on to number 2. It says use a table to write an explicit and recursive rule for the sequence. Alright, so I'm going to make both of them. Explicit right here on this side, and recursive I'll do on this other side. Alright, so let's look at explicit first. Explicit, there are two ways for me to write an explicit rule. I could write f of n equals a, wait, you know what? I don't even know if it's arithmetic or geometric, so let me stop right there. Let's check the sequence. 1, 2, 3, 4, 5, that's the position number, right? And the numbers seem to be changing by -3, right? -3, -3, -3. So that is arithmetic. Let me write that up here. Because it is important based on what type of sequence it is to be able to tell which formula to use. So it is arithmetic. So for arithmetic sequences, it's a plus d times n minus 1, or f of n equals a plus d times n. Both of those would work. It depends on what you call your initial term, right? In this one, a stands for the first term, position number 1. In this one, a stands for the 0 term, position 0. Okay, so that is the difference between the two, what a stands for in each one. So let's see what the table says. The table says that the initial term is 7, which is position 1. So I should use this one. However, you can still use this one even if you want to use these same, even if this one's already starting with position 1, you can still use this one. I'll show you guys how. But let's use this one because it starts with position 1, right? So a is the initial term, which in this case is 7. So it would look like this. F of n equals 7 plus d, which is -3, times n minus 1. And there, it's done. If you want to use this rule, then what you got to do is take the table and go back to position 0 to see what that number would be. And you use that as your initial term. So for example, if this is going -3, -3, -3, if I go backwards, the term before that is 10, right? That would be position 0. So I could write the sequence like this. Using position 0 as 10, I could write f of n equals 10, that would be the initial term now, same d, -3, times n. And that would also be correct. Both of those would be correct. They actually are the exact same thing. Okay, if you guys look at both of those, if you distribute this, actually let me do it, I'm going to do it in blue here. Distribute this, the -3, you'll get 7 minus 3n plus 3. The 7 and the 3 make 10. So it's 10 minus 3n. And look, it's the exact same thing as that one. They actually are the same thing. This one is basically that one after distributing and combining like terms. Both would be correct. And I would accept both on the test. Alright, now for the recursive. The recursive rule has two parts, if you recall. It goes f of n equals f of n minus 1 plus d, whatever d happens to be. And remember, this just means the next term is equal to the previous term plus a number or minus a number. If d is negative, then you would put minus a number. But that's not all. The recursive sequence has two parts. It's f of n equals f of n minus 1 plus d, and you must tell me where to begin. So either f of 0 equals something or f of 1 equals something. Right? One of those two must be there, basically telling the person that is building the sequence where to begin this sequence. And it doesn't matter if you write this first and then this, or this first and then this. Okay, either one or the other. But you just have to tell the person that's building the sequence where to begin. In this case, you should use f of 1 equals 7 because that's what they gave you on the table. F of 1 equals 7. Use that. So it would be this one right here instead of that one. Let's put that there already. So we do not need this one. So f of 1 equals 7, and then the other part, f of n equals f of n minus 1 plus d, these two stay the same. That never changes. The only thing that changes is d. d is negative 3 in this case. So here's your final recursive rule. F of n equals f of n minus 1 minus 3, and f of 1 equals 7. There you go. That's it. Remember, recursive rule is basically instructions. These are instructions. You're telling someone how to build this sequence right here. You're telling them, start with position 1 being 7. That's what you're saying right here. Position 1 is 7. And then after that, to find the next term, take whatever the previous term was and subtract 3. So if the first term is 7, then the second term is 7 minus 3, which is 4. And after that, subtract 3 again and you get 1. Subtract 3 again and you get negative 2, and so on. These are basically instructions on how to build the sequence. Alright, I'm going to let you guys do B and C on your own. So once again, pause the video right now and work on your own, please, for a little while. Okay, here you go. Here's part B and C. In part B, the explicit rule is either f of n equals negative 8 plus 5 n, or f of n equals negative 3 plus 5 times n minus 1. Once again, I did both of them depending on if you're using the 0th term, which is negative 8, or the first term, which is negative 3. If you're using position 1, then you must use n minus 1, you must use negative 3. If you're using position 0, then you must use negative 8 and n instead of n minus 1. For the recursive rule, always the same thing, f of n equals f of n minus 1, plus d, in this case it's plus 5, because it's changing by 5. And f of 0 equals negative 8, which basically tells the person that is building the sequence where to begin, right? Begin at position 0 equals negative 8. For C, the explicit rule, f of n equals 3 plus 1.5 times n minus 1, because position 1 is 3, and the common difference is 1.5. Or 1.5 times n if you're using position 0, for which you would have to go back to see what position 0 is, which is 1.5. So 1.5 plus 1.5 n. Recursive, same as above. The only thing you have to change is d, which is plus 1.5. And this one I did f of 1 equals 3, which is where the table begins. Alright, let's move on to number 3. Use the table to write an explicit and recursive rule for the sequence. So same instructions. I'm guessing that these are not going to be arithmetic. These are going to be geometric, but let's check it out. Let's start with A. Okay, so in A, let's start with the explicit rule on the left side here. Let's do explicit first. And it looks geometric to me, right? It looks like you're starting with negative 8, and then negative 16, which is double, and then negative 32. So you're multiplying times 2 every time. So that means that r is equal to 2. Alright, let me write that down. R is equal to 2. Also, the initial term is position 0, which is negative 8. So let's use that to write our explicit rule. So it's going to look like this. F of n equals a times r to the power of n. I could also do it with to the power of n minus 1, but since they're giving me position 0, I'm just going to stick with that one. Okay? So f of n equals a times r to the power of n. In this case, a is negative 8, so it'll be f of n equals negative 8 times r, which is 2, to the power of n. And there you go. Alright, just so you guys see, what if somebody wants to write it with n minus 1 using position 1? then it would look like this. F of n equals, it's going to be 2 to the power n minus 1 over here, right? But the initial value is no longer negative 8. It would be negative 16 because that is position 1. So you would put negative 16 here instead of negative 8. And that would also be correct. But in this case, since the table started with 4, you are more correct. They're both correct, but if it was possible to be more correct, it would be this one right here because it has position 0, which is what the table starts with. All right, let's look at the recursive rule then. For the recursive rule, it's right over here. It's pretty much the same as the recursive rule for arithmetic sequences. You're going to start with f of n equals f of n minus 1 times something, right? Times r. Most of the time we flip the r and we put it in front. So it's f of n equals equals r times f of n minus 1. Most of the time we flip them and put the r first instead of the f of n minus 1, but it's the same thing, right? Both of those are exactly the same thing. So it doesn't matter if you put r in front or at the end, it still means the same thing. To find the next term, take the previous term and multiply times r. And then you also need the second part, which is where to begin the sequence. So in this case, we said that r is equal to 2, right? Because it's being multiplied times 2. So r is equal to 2, so this is what it's going to look like. F of n equals 2 times f of n minus 1. And the table starts at f of 0 equals negative 8, so write that. F of 0 equals negative 8. You always need the two pieces for a recursive rule. You need the pattern, which is this, 2 times something, and the beginning, the starting point. You start at position 0 equals negative 8. And then the pattern is to keep multiplying times 2. That's what this is saying. So you can find the next one by multiplying times 2 and times 2 and times 2 and so on. Okay, once again, B and C are yours, so go for it. Go ahead and pause the video right now and work on your own for a little while. Okay, here you go. These are the solutions for B and C. In B, in the explicit rule, I started with A equals 16, the initial term. R is 1/2 because you notice that it's being multiplied by 1/2. It's dividing by 2, but we don't care about dividing. We care about multiplying. So it's multiplying by 1/2. And I use 16 as the initial term, therefore I use n minus 1 here. The other way of writing it would be to use n instead of n minus 1, but in that case you would have to use position 0, whatever that is. So you would have to go backwards. Position 0, if you go backwards, would be 32, so that's why I put 32 times 1/2 to the power of n. For the recursive rule, f of n equals, here's r times f of n minus 1. It always looks the same. Again, sometimes we put the r at the end, right? But it's always going to look the same. The only thing that matters here is r. Everything else is the same. And you tell me how to start the sequence. You start at position 1 equals 16, so that's why I wrote that there. Both of these are part of the recursive. In C, the explicit rule is 9 times r, which is 1/3 to the power of n, and just n because 9 is position 0. Position 1 is 3, so 3 times 1/3 to the power of n minus 1. Hi, baby. Hi. Alright, and that was my son interrupting us. Okay, let's keep going. You can also see here the recursive rule, which it looks like I messed up, right? This should not say explicit, it should say recursive. The recursive rule is 1/3 times f of n minus 1, and position 0 is 9, which is what they're giving me there, so that I wrote that there. Okay, r is 1/3. The recursive rule always looks the same. Alright, let's move on to number 4. 4a. Your new job pays $20,000 for the first year. You are guaranteed a raise of 5% every year. You leave that job after exactly 5 years. How much do you make on your last year? How much did you make total? Okay, so if I wanted to start a sequence with this, it would start with 20,000. That's how much you make on your first year. The next year, it's going to be some other number increasing by 5% because you got a 5% raise. So this is year 1. Let's call this year 1. And then the next one will be year 2 and so on. So the question is, how much will you get on your 5th year? This is year 1, then year 2, then year 3, then year 4. The question is, how much will you get on your 5th year? And also, how much did you get total in all 5 years, right? So let's answer the first question. To answer the first question, what you need is not the sum, right? You don't need the sum formula. You don't need this. That is when you're trying to add all the numbers. We're going to need that one to answer this second question. What is the total? Right now, what we just want to know is, what is this number? What is the 5th year only by itself? To answer that question, you need the sequence formula. You need f of n equals a times r to the power of n minus 1, right? N minus 1 because we're saying that this is the 1st year. So a times r to the power of n minus 1. That's what we're going to use. In this case, a is 20,000. So 20,000 right here. 20,000 times r, which is, oh, let's figure that out. We practiced this before, but it's a raise of 5%. I'm trying to figure out what r is. A raise of 5%. Think about it. Remember, we practiced these a lot. 5% means 0.05, right, in decimal form. And it's a raise. That means it's increasing. So remember what we said. Any percent increase, you take that number, turn it into a decimal, and add 1. So it's 1 plus 0.05, which is 1.05. That's your r. If it was decreasing, you would say 1 minus 0.05. But it's increasing, so 1.05. That is r. Let's plug that in. And n is how many years, which part of this, which term in the sequence you're looking for. N in this case represents which term are you looking for. We're looking for the 5th term, right? Or how much did you make on your last year? This is the 1st year, this is the 5th year. So you're looking for the 5th term. Alright, and now at this point it's just calculator work. You gotta take 20,000 and multiply it by 1.05 to the power of 4. Let's punch that into a calculator. Calculator says 1.2155, right? Make sure you guys are being careful with this. It's 5 minus 1, so it's 4. Okay, so make sure you're careful. 1.2155. Actually, let's keep it going a little more, a couple more decimal places, because we're going to be multiplying by 20,000, so I don't want to lose any dollar. 0.625. Now multiply that by 20,000. And so that's $24,310.16. That is the 5th year. That is your salary on your 5th year on this job, in which you made 20,000 your 1st year and then it got a 5% raise every single year. That's the 5th year. Actually, let me write it in right there. 24,310.16. Now the other question, how much did you make total? For that question, to answer that question, we need this formula. The sum formula. You got to make sure you identify what kind of sum this is. This is geometric, right? This is a geometric series. So you need this formula. A times 1 minus r to the power of n over 1 minus r. In this case, A is 20,000 once again. R is 1.05 once again. N is how many terms you're adding. Let's just double check real quick. 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 terms, so N is 5. Plug in all those numbers into your sum formula and that'll give you your final answer. So S of 5 equals A, which is 20,000. I left a 0 there. 20,000 times 1 minus 1.05 to the power of 5 all over 1 minus 1.05. And once again, at that point, it's calculator work. Make sure you're punching it all in correctly. 20,000 times, I'm going to do 1 minus 1.05 to the 5th power on my calculator. And I got 0.276281 5625 over negative 0.05. And I'm going to finish that off on the calculator. Oh, this one's also negative. Forgot to see that. Let's fix that. The number in the numerator is also negative, so make sure we fix that. It's 20,000, and this is negative 0.27 something something something. So they're both negative. That means when I divide them, it's going to be a positive, right? Negative divided by negative. All right, let's finish it. Divide those and multiply them by 20,000. That means, actually I'm going to keep it up, going up here. 20,000 times, let's divide. Calculator says 5.52. 52563. 52563. 125. And finally multiply that times 20,000. And I get 110,512 and 63 cents. And that is your total amount of money that you make in 5 years with that company. Alright, let's do one more together. Part B. Your new car is worth $30,000. Every year it depreciates by 20%. How much is the car worth 6 years after you bought it? Okay, make sure you pay attention to the question that is asked. How much is the car worth 6 years after you bought it? So it's saying that on the first year it's 30,000. Actually, not even on the first year. When you buy it, it's 30,000. When you buy it, no years have passed, right? So actually that 30,000 represents the 0 year. And then 1 year after you buy it, oops, should have put that there. 1 year after you bought it, now it's worth something else, right? Some number there. And then 2 years after you buy it, it's worth something else, some number there, and so on, right? So it's saying, what is the car worth 6 years after you bought it, right? So really you're looking for this one right here, okay? Are you looking for the total sum of all of these numbers? No, you're not, right? You don't care about how much the car is worth when you bought it, plus the first year, plus the second year, right? You don't want the total. You just want to know, what is this number right here? What is the 6th term on this sequence that starts with 0? Alright, so using that information, now we can figure it out. We don't need the sum formula in this case. We just need f of n equals a times r to the power of n. Since I'm starting with position 0 for when you buy the car, I'm going to use n, not n minus 1. But I will try to figure out what the 6th term, so I will plug in 6 in there to find this one right here. Alright, a is 30,000, so f of n equals 30,000 times r, which is, we haven't figured out r yet. Alright, we skipped that part. Let's do it right now. What is r? It says that it depreciates by 20%. That means it loses its value by 20% every year. So that means that it's instead of increasing, it's decreasing 20%. So first change 20% to a decimal. That's 0.20. So 20% is 0.20 or 0.2. So what you got to do is you got to say 1 minus 0.2, right? 1 minus that. That is your r. And that will be 0.8 or 0.80, which is the same thing. All right, we found our r. Let's plug it in. 0.8 to the power of n, and we just said we're looking for the 6th term, right? Position 6. So plug in 6 for n. And again, that is calculator work. Okay, actually you can enter the entire thing as it is written right here on your calculator to get your final answer. Let's see what it says. And my calculator says that it's 78.6432. Your car is now worth $7,864.32 after 6 years. 6 years after you bought it. So once again, before I move on to the next one, notice that we did not have to find the total sum. We didn't use this formula, right? That one. We didn't use that one. Because we don't need to find the total sum of all of the values of the car, right? We don't add, oh, this year's worth 30,000, next year's worth 24,000 or something. We don't add those up, right? We just care about what is the sixth term in the sequence. So we just use the sequence formula, not the sum formula. Okay, C and D are yours. All right, so I want you guys to try to work those out. Go for it. Pause the video right now, do them on your own, and then come back and check your answers. Go ahead and pause the video now. Alright, here are the solutions for C and D. In C, I am using A to be 165,000 and R is 1.02. 1.02 because it's growing by 2%, right? So 1 plus 0.02 is 1.02. I set 165,000 to be year 0. The reason for that is because it says what will be the population in 20 years. So 20 years from now. So if this is now, 20 years will be 1 year from now, 2 years from now, and so on. Okay, so that only makes sense that to call this one position 0. So I'm using this formula instead of the n minus 1. And notice again that it's not asking for the total sum of all the populations. It's only asking for the 20th year. So I use the formula using A equals 165,000, R equals 1.02, N equals 20 for the 20th year, and I came up with 245,181 people. Note decimals because we're talking about people. You're not going to chop them off into pieces, right? For D, it says that the first week, right? So they're telling me it's the first week. It's not the 0th week. It's the first week, 25 cases. And it's asking me about the 10th week. So I call this one the first week, and then this one's going to be the 10th week. The number of new cases increases by 50%. So that means that R is 1.5. It's increasing by 50%. So 1 plus 0.5 is 1.5. So I use this formula to figure out the total number of cases on the 10th week. So I plugged in 10 for n, so it's 10 minus 1, 1.5 to the 9th power, times the initial, which is 25. I got 961 point something, but it doesn't matter because we're talking about cases of flu, so that means people infected, so 961 total. Then the second question is how many total cases are reported in all 10 weeks. So that means add this one, plus the second week, plus the third week, and so on. So we use this formula for the sum. A is still 25. N is 10 because there are 10 numbers being added. I know that because if the first one is for 1 and the last one is 10, then there's a total of 10. You can just count them. So 1.5 to the power of 10 is right here, r to the n power. Basically after this point is just calculator work, right? The negative divided by negative is a positive, then multiply times 25 is 2833 point something. I think I got 0.25, but it doesn't matter because we're talking about flu cases, so people infected. So 2,833 total after 10 weeks on the 10th week. Alright, let's move on to number 5. Write the terms of the given geometric sequence and then graph the sequence. Okay, so it's a geometric sequence that they gave me here. I know it's geometric, one, because they told me here, and second, because of the rule. I can see that it's a power where the n is an exponent. So, to find these terms, all you gotta do, since this is the explicit rule, right, you guys can see that it's a times r to the power of n. All you gotta do is just plug in the numbers. Plug in 0, see what you get. Plug in 1, see what you get, and so on. And that'll give you these numbers. And then you just plot them and you're done. So let's do it. Plug in 0 right here. 1.5 to the power of 0 is 1, right? Anything to the 0 power is 1. So 4 times 1 is 4. This one is 4. The next one, plug in 1. 1.5 to the power of 1, that's 1.5. Times 4, 1.5 times 4 is 6. 1.5 to the power of 2. Right here, plug in 2. 1.5 to the power of 2. That is 9/4 times 4 is 9. That's 9. Alright, we keep going. Plug in 3. Plug in 3 right there to see what you get. So that'll be 9 times 3 halves, 27 halves. I'm going to write it as a fraction. Or as a decimal, it will be 13.5. Same thing. And last one, plug in 4, 1.5 to the 4th power. That's going to be times 3 halves. It's going to be 81 fourths. 81 over 4. Or as a decimal, it will be 20.25. Either one is correct. Alright, those are the numbers. All you got to do is just not plot them on the graph and you're done. 0, 4, 0, 4 right here. 1, 6 is right here. 2, 9 is right here. And those are the only ones that fit. The other ones don't fit. And that's it. You're done. Do not connect them. This represents a sequence. If for sequence, only these terms exist on the sequence. The other ones do not. So just leave it alone like that. Alright. I'm going to let you guys work on B and C. So go ahead and do those on your own, please. And then pause the video, come back and check your answers. Pause the video right now so you can work on your own. Alright, here you go. These are the solutions for B and C. In B, I got 9 for the first term by plugging in 1. It's 18 times 1 half, which is 9. And then after that, everything is times 1 half. 9 times 1 half is 9 half, which is 4.5. And then 9 fourths, which is 2.25, and so on. And here are the points that I graphed. 1 is 9, 2 is 4.5, and so on. Once again, do not connect them because these are supposed to be discrete. For C, my first term when I plug in 1 is 8. So 24 times 1/3 to the power 1 is 8. And then after that, it's basically times 1/3 times 1/3 times 1/3. And I got these numbers, approximately 2.67, approximately 0.89, and so on. And here are my points. As you can see, it's getting closer and closer to 0. But actually, it's never going to reach it. It's one of those that I talked about where this is called an asymptote that is never going to actually reach. You could make this 6, and it's going to get tinier and tinier, but it will never reach the x-axis. It will never actually reach 0. Alright, part D, let's work on this one together, and then I think I'll let you guys work on E and F on your own. So part D, it's saying f of 0 equals 2, and f of n equals 2 times f to the f of n minus 1. So this is a recursive rule, right? It's telling me that f of 0, the initial term, which is 0, is 2. Now in the table, I didn't put a 0, I put a 1. So you can't put the 2 here, right? You need to figure out what is the first term. If the 0 term is 2, what is the first term? And you find that by looking at the rule here. The rule is saying to find the next term, take the previous term and multiply it times 2. So basically take any term and multiply it times 2. Now if the 0 term is 2, then the next term is 4. Right? You just keep multiplying times 2 to find the next one. That's what the recursive rule is trying to tell you. To find the next term, take the previous and multiply times 2. So I'm going to multiply times 2 again, and I'm going to get 8. And times 2 again, and I'm going to get 16, and then 32, and then 64. And there you go. Plot those points, and you're done. 1, 4 is right here. 2, 8 is right here. 3, 16 doesn't fit. Okay, well, I guess I made the graph a little too small to plot all those points. But it would be way, way up there, right? But that's enough for this graph because those are the only two that fit. No, actually, I'll stop right there. You guys work on E and D on your own. Okay, so E and D are for you. Go ahead and try them on your own. Pause the video right now so you guys can work on your own, then come back and check the answer. Okay, here you go. Here's the correct answers for E and F. In E, they told you what the first term is. See how it says f of 1 equals 18? So that's where you start. And then use the rule, which is saying to find the next term, multiply by 1/3 to find the next one. So 18 times 1/3, I got 6. Times 1/3 again, I got 2. Times 1/3 again, I got 2/3, which is 0.67. Times 1/3 again, I got 2/9, which is 0.2 repeating decimal. So here are the 3 that I could graph. The other ones did not fit, right? 18 doesn't fit. But here's the 3 that I could graph. In F, it's telling you that f of 0 is 24, so that goes here. But what you want is the first term, And here's the rule. It says multiply times 1/2. So keep multiplying times 1/2 to find the next one and the next one. 24 times 1/2 is 12. 6, 2, 1, 1/2, right? You keep cutting everything in half. And here are the 3 that I could fit into the graph. 112 almost fit. It's up here, but it would be often on the table over here. But it will be somewhere up here. But these are the 3 you could fit.